we're going to apply the limit here. The first thing we're going to do, basically with all these limit problems, is yeah, we can acknowledge the domain. But if you want to keep it simple, you could just take this number, you could plug in and see if it works. If it works, you've got your limit. So if we take 5 and we insert 5 in for all the x's, and we evaluate that function basically at 5, we know we get 39 back. Hey, we plug the number in, we got a real result, we got our limit. We're done. So if we're taking the limit on this problem, start with what x is approaching, plug it in for all the x's you see within the function, and see if it works. You get a real result back, you're done. You got your limit. Go ahead and write out a few more steps here since we got more x's to play with. We'll have negative 2 that we're cubing, plus 2 times negative 2 squared. We're going to subtract 1, and that's all going to be over 5 minus 3 times negative 2. Now, one thing I want you to understand also is this limit is telling me to take that negative 2 and plug in. And once I plug that negative 2 in, I'm done with that limit notation. Okay, I've applied that idea. So that's why over here, as you see all the substitution, there's no more limit notation. That's important, and it's going to become more and more important for us as we go along. So evaluating this, let's see, negative 2 cubed is going to be negative 8, plus 2 times negative 2 squared, so that's going to be 2 times 4, that's going to be 8, minus 1, all over, denominator you got 5, minus 3, negative 2, multiply that together, it's going to be positive 6, so that's going to be 11, right? Basically got negative 1 over 11 back, which is a real answer. And since it's a real answer, we know that our limit as x approaches negative 2 applied to this function is going to be that answer of negative 111. Good. Any limit problem, you're going to start with what x is approaching. You're going to take that value, you're going to plug in, you're going to see if you get a real result. If you do, great, you got your answer. And we did that on the first couple of problems. Here, we understand if we plug in 1, we get 0 over 0 back, which is an indeterminate value, and that means we have to do more. So what we do is we carry this limit over. We carry it over because we plugged in 1, it didn't work, so apparently I'm not ready to play with the limit just yet. Instead, what I'm going to play with, that function. I'm going to manipulate it so that I can make it work. There's basically 2 strategies that we use as we introduce this idea in this packet. The first of those strategies that we're going to see here today is factoring. You have to ask yourself, when you plug in and you get 0 over 0 back, is that expression something I can factor? If it is, factor it out. And if you're getting 0 over 0 back, it will be factorable for what we're doing here today. You got a difference of 2 squares in the numerator. That factors to x minus 1, x plus 1. That is all over the x minus 1 that's originally in the denominator. Well, that's interesting. We got some factors that are being shared here between numerator and denominator of x minus 1. I can take that out. This expression, this original function I'm applying the limit to, does simplify. So we got the limit as x approaches 1, applied to now the simplified form of x plus 1. We've manipulated the function as much as we can. Let's plug the limit in again. Let's plug in that 1. 1 goes in the place of x. 1 plus 1 is 2. That's a real result. That means the original limit here we were trying to evaluate equals 2.